handheld 3D scanning into SolidWorks with the DPI-8X handheld 3D scanner and InfiPoints DP on Android. First off, a little bit of background on us. For those on the line who may be new to DotProduct, we're a leading handheld 3D scanning company. So what we do is we provide a complete solution to industries of a wide variety, looking to capture accurate, measurable, as-built information of existing conditions. With our flagship products, the DPI-8X and DPI-8X SR, Android-based handheld 3D scanners. Our core technology is the software, which we'll be going through in detail today. Phi3D is the Android scanning software, and Dot3D Edit is our editing solution on Android and Windows.
So let me just add on a few things about myself as well. My name is Shun Higashida again from Elysium. I'm based in Hamamatsu, Japan. I'll do a little bit of a company introduction about the middle of the presentation today, but just a little word about my company. We focus on 3D geometry and 3D data translation, as well as handling point cloud data, where we ended up with partnering with DotProduct with the technology that we'll introduce today. So go ahead, Chris.
Perfect, thank you. And yeah, as you can see, we're broadcasting from all over the globe. DotProduct is headquartered here in Boston, although we're also based out of Wiesbaden, Germany, and Houston, Texas. So a little bit more on the product itself and the technology that you'll be seeing live today. This is our core handheld 3D scanning solution, the DotProduct DPI-8X, and also the DPI-8X SR. Today we'll be showing the DPI-8X, which is the standard model. The SR is a slightly shorter range version of the same technology. On the hardware side, it's a component of parts. So it's a 3D sensor that's built into the back of the tablet itself, and our software is the core technology that's enabling all of this on the Phi3D and Dot3D software on Android. A little bit more about why we came out with this technology, what problems we're solving, and what the overall solution provides. So we saw a gap in the market as far as traditional tripod and terrestrial laser scanning options for a solution that was truly mobile, where you could actually walk around from any angle to capture really hard to reach or complex areas. Very simple to use, so it's not something that requires a week's training to get any single person in your company up and running with. Something that field workers can use. It can be deployed as a tool very rapidly. Completely handheld, so no tripod needed whatsoever. Inexpensive at under $6,000 for the total cost of all the hardware and software included that you'll see today, and accurate. So it's engineering grade data that can be used for renovation, retrofit, even reverse engineering of large parts. And it's real time, so you know what you have in the field. As you see today, you actually get to look at the data as you capture it and review it immediately after, and take it from start to finish through cropping and even into InfiPoints for feature extraction. Briefly, a little bit more on the hardware. So the tablet we use here is an NVIDIA Shield tablet. This is a powerful Android tablet designed for gaming, which of course works very well with what we do because it has a great processing chip, extra memory, and a very powerful and clean HD touchscreen. The sensor is a PrimeSense Carmine, and this is an infrared structured light sensor that's giving us all of our 3D data information and color overlay at 30 frames per second. Our software is reading that in and stitching it together on the fly. Our core technology since the start of the company has been our Phi3D scanning software. This is the 3D reconstruction software that's taking all that depth mapped RGB data and stitching it together accurately on the tablet. It's giving us dimensionally accurate 3D and reconstructing it instantly. It's giving us real-time feedback on the quality of the points we're collecting, which you'll see live shortly, where you get green and yellow feedback while you're scanning. It's a highly compressed output, so small you can often email it right off the tablet, even in point cloud format. Today we'll be emailing an IGES file extracted from InfiPoints DP live on the tablet. You can immediately view, measure, set coordinates, and a lot more in Dot3D. And we also have advanced features built in where you can append multiple data sets together on the fly, or you can optionally introduce targets to give you the absolute highest level of accuracy in your data set, especially over larger areas. We're also excited to announce that we're coming out with Dot3D 2.2 earlier this morning as well. So this is a new release to our Phi3D 2.2, our Phi3D scanning software. I'll demonstrate today the core functionality that we've introduced is the parallel surface constraints. This is an optional workflow that will allow you to reference flat surfaces in your scan that you want to lock in very tightly to be a flat surface across large areas. For example, top and bottom of a staircase, you can reference parallel planes. Or if you're unable to close the loop across a long hallway, you can reference that same floor, should be locked in tight from start to finish. Additionally, we have improved relocalization, Android 7 compatibility improvements, additional optional staircase functions for advanced staircase scanning functionality, UI improvements, and bug fixes. Also today, we're releasing the 2.0 release, so a major release of our new .3D editing software. So this functions the same on Android or Windows today as we move through the 3 stages from 5.3D to .3D to InfiPoints DP. You'll be seeing it all happen on an Android tablet, although this can also be done on a Windows machine. It's a full screen viewer with advanced measurement capabilities, very powerful and easy cropping utilities, even on a touch screen, and full annotation capabilities to add notes into your 3D data. Some of the new features coming out in 2.0 include surface measurements. You can recognize and annotate surfaces in your scene and measure perpendicularly out of them to get clearances, from a wall to a part, floor to a part, ceiling to part, etc. You can also get area measurements out of that, and you can get cylinder recognition and diameter measurements out of that as well. So much more measurement functionality, additional export options for maximum compatibility, as we're now exporting to E57, LAS, LAZ, and POD. As you'll see today, we've also added a view change between ortho and perspective. So this is allowing for improvements in your cropping capabilities and better floor plan view while looking at the data in .3D. You can also now set and manage your coordinate system in .3D. This is something we've had in 5.3D for quite a while. We're glad to now have brought it into .3D. Similarly, for those who have used these products already, we're glad to have now added April tags optimization into .3D. So this is using our intelligent smart targets. In the past, you've had to do that optimization in the field. You can now do it back on Windows as well. In addition, we've added batch optimization. So if you do a lot of scans in the field, you want to optimize them all back on the PC, that's now an option as well. But I'll be getting into more of this and showing it live. A little bit on the growing commercial use of our technology. So we fit into a lot of different niches, from large scale industries like construction, industrial facility management, engineering, and product design. So those are a lot of industries that are very experienced with 3D data, whether it be the laser scan and capture side of it, or the CAD design side of it, or more often than not, both. And they see a really good fit for a easily deployable small scale solution for capturing dense color detail of small parts, small rooms, hard to reach areas, etc. In addition, we have growing markets across the globe that fit a different description. It's a situation where they may not be as experienced with 3D, but they are replacing what is simply photograph, sketchpad, tape measure in the past with so much more information obtained so much more easily and completely using the DPI-8X. So that is your crime scene forensics, archaeology and heritage preservation, insurance documentation, and custom design and installation projects. So even home renovation projects where you want to renovate a staircase, a kitchen, etc. You capture all the existing information with the DPI-8X and you use that as your reference data in the design process. A little bit about the challenges of working with scan data, both in general and specifically as it applies to this use case today. So often very large file sizes when you talk about point cloud data, laser scan data. The DP point cloud files we work with on the DotProduct DPI-8X are only from 10 to 45 megabytes. So that makes them so small, you can often email them right off the tablet, even in point cloud format. That'll import directly into 30 plus 3D applications to date, including InfiPoints DP, and also the full-featured desktop version of InfiPoints, which Shun will get into later. So another challenge could be if the data may be incompatible or challenging to use, at least, with many surface-based CAD applications. So they don't like the millions and millions of XYZ color coordinates that we've captured. While it is a lot of very important information, it can be heavy for some of these surface-based CAD applications to deal with. And that's one of the main reasons why we're demonstrating today the workflow into SolidWorks. SolidWorks is not, does not work very well with true point cloud data by any means. So with this conversion, we're able to produce a very lightweight, clean, selectable CAD file based on simple surfaces and cylinders in the scene. So we'll get into that more shortly. Some of the challenges of manipulating in 3D design applications. So Dot3D Edit is improving that workflow by allowing initial cropping and measurement right away. And InfiPoints DP is giving us those surfaces and cylinders that can be manipulated just like other CAD objects within a program like SolidWorks, Creo, other solid-based CAD applications. And now I'll pass it back to Shun to go through a little bit more on Elysium, InfiPoints, and then we'll move on to InfiPoints DP in the live demo.
Okay, so thank you, Chris, for your introduction to your company and your product and the obstacles that we have with Point Cloud. So before we get into the demonstration and about InfiPoints DP itself, let me talk a little bit about Elysium. Our company is based off in Hamamatsu, Japan. We have our global headquarters in Japan, but we also have our offices in the US as well as in Europe. So we have our presence all over the world, and our core competence is in 3D data handling, especially in handling 3D complex 3D geometry. Where we come out of is data translation. We have multiple relations with all the most and all of the major CAD vendors, and SolidWorks included, including SolidWorks, of course, for today's presentation. And we've been working with those kind of CAD vendors and utilizing those genuine APIs of the CAD vendors that the CAD vendors provide. We're able to realize high quality translation of the 3D geometry, and then not just 3D geometry, but other information such as attributes and PMIs, with rising demand for more high quality and model-based definition schemas. But recently, we've been going into point clouds, which is another extension of how we would like to handle 3D geometry as a whole. And the product that we handle point cloud is called InfiPoints. And if you go on to the next page, so InfiPoints is the large-scale point cloud handling tool. It's developed by Elysium ourselves. And this is a tool that can handle billions of points, regardless of number of scans. And supporting multiple scanner formats, of course, including the DP file that DotProduct scanner produces. And not only the handheld scanners, but tripod scanners, aerial scans, and things like that is also supported in InfiPoints. And we have applications in shipbuilding, plant engineering, manufacturing, construction, architecture, you name it. And our strength in our technology is that we have a one-stop solution from the data registration or the data pre-processing all the way to creating your outputs. And within that process, we're using our sophisticated 3D data handling technology. We have the capability to extract surfaces or surfaces from the point cloud data, which is one of the core functionalities of today's presentation. And also with the relationship and the experience we've had with all the mechanical CAD systems, we have interoperability with the CAD systems, which, for example, a step or parasolid format, which is much more friendly in using with other systems outside of the point cloud world. So on the next page, we introduce a little bit about what InfiPoints is. This is a video that's also available on YouTube, so feel free to take a look at it if you're interested. So basically, our InfiPoints product is able to extract these kind of cylinders as pipes or create steel structures, and all the in the planes, of course. You can utilize those geometry to create drawings or viewer files or videos, and easy measurements inside of the environment. And whatever the your workflow is in point clouds, we maximize the point cloud possibility itself. So not only do we have the capability to model information, but we also have the capability to utilize the point clouds for interference checking and simulation. And recently, we also added a technology to support VR. So not only viewing the point cloud inside of the computer, but using the Oculus Rift is what we support. You can go into the point cloud environment immersively and experience for yourself. Have a human experience of what it's like on site. So that's kind of the introduction to Elysium and to InfiPoints.
Thank you very much. A great introduction to InfiPoints and Elysium, and now moving into what we're going to be showing today, which is a powerful small piece of the full InfiPoints solution that we're lucky enough to have developed specifically for the DotProduct DPI-8X, and that is InfiPoints DP. So this is an Android application that runs right on your scanner and allows you to just hit send InfiPoints from either Phi3D or Dot3D, and it immediately begins an automatic feature extraction from the data. So any surfaces that are recognized in the data, any pipes and cylinders that are recognized in the data are automatically created as individual CAD objects within this small, lightweight Android application. The direct export options, as you see in the top left of the screen on the demo video here, are IGES and DWG, and that makes for a very easy import into a program like SolidWorks. You can review the data as soon as you send it over right on the tablet, so you can see what you have captured. And then from here, it's a fully functioning Android tablet. So what we're going to do today is just email it right from there to Shun, so we can bring it into SolidWorks. And here's a image demonstration of what you're about to see live. So on the left side, you'll see Phi3D, that's our laser scanning app. In the middle, you'll see Dot3D, which is our point cloud editing app. And on the right, you'll see InfiPoints DP, which is the automatic feature extraction stage. And that'll give us our solid model file for export. So with that, we're going to go ahead and switch over to the live demo side of things. Knock on wood, it should go flawlessly, but we're not faking anything here. So bear with us as we do this entire process completely live. So the next step is we're actually going to switch the presenter privileges over to my DPI-8X scanner itself. I'm going to broadcast directly from my Android tablet. So you should now all see my tablet screen. And here we see I've opened up Phi3D. So this is our initial 3D scanning application. You'll see we're going to be scanning today a demo pipe spool and some walls in a residential area. So this will give us a really good example of both the surfaces and the pipes that will be extracted automatically from your data. I'm letting that session warm up process. This is just a simple 20 to 30 second warm up required by the sensor between each scan. And as soon as that turns green and fills up, I'm going to hit start scanning. As soon as I hit start mapping, you'll immediately see green and yellow feedback on the quality of the points I'm collecting. As we are broadcasting this live off of a tablet with a live camera feed, there may be some choppiness in the data or in the feed. So I'll try and move slowly and talk slowly through the scan. This target that you see on the floor is called an April tag. It turns orange automatically to show it's been recognized. And that's a very easy workflow optionally to improve the accuracy of your data without any extra measurement or manual input whatsoever. It's basically just a reference point to loop back over multiple times within your scan. And anytime you capture that same tag, it recognizes that it's been the exact same point, and it'll use that to keep your data nice and tight. In addition, we're operating the brand new Phi3D 2.2 version here. And similarly to the reference points that we use with the April tag, you can also reference planes that should be locked in throughout your scan. So if I hold for picking plane, it'll recognize that surface. And this isn't the best example as I'm just scanning a small area, but let's say I scanned a bunch of the ceiling and came to a whole different side of the office here, and I wanted to recognize that same floor on the other side. You could again hit hold for picking plane, and it's referencing that those planes should be locked in nice and flat across your scan. So as far as the colors go, the yellow is good, green is great, so I'm making sure to turn this pipe nice and green. Fill in any holes in your data. You can actually see those shadows in real time, which is very different than the traditional workflow if you're using tripod laser scanning, where you don't know what you have and what you have not captured until you're most likely back in the office looking at it. So now that I've captured a pretty complete scan of this pipe, I'll finish back at that same April tag that I started at to close the loop nicely. It quickly post-processes the data and gives you a preview immediately right on the tablet. So here we can have a look at our data and make sure we captured everything we need. Looks like a very good scan of the pipe and the walls around it. And the next step is always going to be optimization. Unless I realize I missed something here, we do have the unique ability to append where I can go back and add directly into my same file. However, in this case, it looks like I've gotten everything I need, so I'm going to go ahead and move on to optimization. So I select that OPT tab and global optimization. With the new Phi3D 2.2, if you have recognized planes like we did on the floor, you're going to want to leave that box checked to use that constraint as a reference during your optimization. And you'll also want to hit yes to use April tags at this intermediary screen. So the optimization step takes anywhere between 30 seconds and maybe at most 3 or 4 minutes, depending on the size of the scan that was captured. A nice new feature, as I mentioned earlier, in today's release of .3D 2.0 is that you could be processing this in bulk on the Windows version of .3D, so you don't necessarily have to do it all in the field on Android. And in general, you don't have to do it in the field. You can also save your unoptimized data if you're trying to maximize time on site or battery life on the scanner. In addition to the April tags or the plane constraints, even if you're just optimizing a scan without any of that, what's happening here is it's leveling the colors throughout the scan. It's cleaning up any noise that it recognizes in the data. It's tightening the frame-to-frame alignment based on a variety of factors and improving the overall accuracy and quality of your data. So it's something that you do want to do with every scan. Optionally, if you had introduced any targeting constraints, so this could be survey control points or scale bar target references, those are all taken into account during the post-processing optimization stage as well. So it's just finishing up here, and we'll see our nice cleaned up data set within Phi3D. So you'll notice the colors have brightened up a bit. The scan looks very crisp and clean. We have 2 different viewpoint options within Phi3D and .3D, depending on your personal preference or what you're looking at. This is the photo-based rendering, which gives it that photorealistic look, but can sometimes be a little choppy on edges. And we also have the point cloud view, if I select in the bottom left of my screen, that will give you a better impression of every single XYZ color coordinate that was captured. So this is showing a little bit choppy maybe in the broadcast, but all of the coordinates that we've captured in the point cloud. The next step is going to be to set a coordinate system. So if I move from optimization to the coordinates tab, I can set an origin point to reference my data, or I can set any known coordinate if I'm trying to reference it to another point cloud or a model, for example. In this case, I'll just set an origin in the corner. So I'll tap the corner of my scan, set my Z-axis straight up by tapping that primary button and selecting a point on the floor. and I'll set my x-axis straight out of the wall by tapping a point in the wall. You can also take measurements directly from within Phi3D from any point to point in your scan. I'll also be demonstrating measurement in Dot3D as well, so I won't take too much time here, but one unique function that we do have in Phi3D is a frame view measurement, where I can actually switch to image frames captured during my scanning and tap those directly. So if I want to do a new measurement, I can zoom in, tap a point on the pipe. I can go back to my frames and select the next point that I want to measure from. And then I switch back to my 3D view, and it automatically has given me the measurement in 3D that I selected from those image frames. Additionally, if I wanted to measure a clearance of the pipe, for example, I can measure based off of the coordinate system that I just captured. So I can do a new measurement from floor to pipe. Oops. From floor to pipe. And it gives me not only my direct point-to-point distance, but it also gives me in the bottom right of my screen my change in X, change in Y, and change in Z. Next step is going to be to go back to the top left to my File tab and select Save Scene. We will call this InfiPoints DP webinar. And I like to indicate that I have optimized and set the coordinates with an OC. I want to use my user-defined transform that's saying use the coordinates that I just set, and select Save Scene. So now that we've finished working with the data in Phi3D, we're going to move on to Dot3D for some more editing, measurement, and then to send to InfiPoints DP from there. So I'll select Send Scene to, open with Dot3D. So now we see the entire scene in our full screen viewer and editor, Dot3D Edit on Android. The first step here in Dot3D will often be to crop and clean your data. So this is really powerful to be able to do on Android in the field because it gives you an even smaller file size, an even cleaner file. And the fact that you can do it so easily on a touchscreen is very nice. So I'll select Edit Crop. And I can use this box to select anything I want to keep or anything I want to crop out. But before I do that, I'm going to switch to a different viewpoint, which is a new function in Dot3D 2.0, which allows me to look at my data based on the coordinate system that was set automatically from the direct top view. Next, I can also now switch from the perspective view to an orthographic view, which will give me a truer floor plan and can be very helpful when cropping. So now that I'm looking directly from above in my ortho view, I can select the area of interest. And then if I do view vantage points front, now I can crop out the above area that I don't want as well. I'll hit deselect in this case and actually hit invert. And the invert will make everything red that I don't want. Maybe I can get rid of a little bit on this side as well. It's a full multi-crop functionality. And hit crop. So now we have this even smaller, cleaner file. This also goes for if I was to be registering the data with a tripod scan, for example. You don't want any of those stray points to be involved in that registration. Those are your lower quality points. So it's always good to crop out what you don't want and avoid having to deal with it later. The measurement functionality that we have built in here in Dot3D is significantly improved from Phi3D. So if I want to measure that same point to point on this pipe, for example, I select and hold, and then select and hold. But I really don't have to be so precise with my point picking anymore because I am actually able to drag that endpoint, and it's actually snapping from point to point if I switch to the point cloud view. So it's really as precise as you can get with a point cloud measurement when you have those draggable endpoints here in Dot3D. You can change your units right here to whatever it is that you want to measure from and move those around. You similarly still get the same change in X, change in Y, change in Z, and you can adjust the measurement on the fly to see that. Are you still with me on this, Shun? I'm seeing a frozen screen on my end.
Actually, I'm seeing a frozen screen on my end too.
Okay, 1 second here. Bear with us, guys. So here's our cropped scan. And if I want to annotate that, as I was mentioning, and actually doing live before I realized it was frozen, I can add a point annotation with the exact 3D location and any details that you want to add in there very easily. This is a feature we had in .3D 1.0. The new annotation functionality is that I can actually annotate to surfaces and cylinders in my scan. So if I want to recognize that back wall, I'll select Annotate Plane, and it'll recognize that plane behind the pipe. This is really useful for measurement functionality. So not only can I view my surface area automatically if I select the pencil icon and bring up the detailed information on my plane, but I can also measure out of that plane to get different clearances. So if I want to find out how much space I have for a new part to go in between this wall and this pipe, I go to the Measurement tab, and I hold to select the surface plane as my measurement point, and then I hold to select a different point on the pipe. Now I can drag that around and get all my different clearances automatically directly pulled perpendicularly out of that wall. Additionally, we can recognize a cylinder, so recognize that pipe, and that will give you the ability, if you tap your pencil, to see the location and also the diameter of the pipe as pulled from .3D. As we always have in .3D, we have a very simple but useful functionality to take strategic screenshots if I want to capture just the data and annotation and measurement information and not any of the menu items, and then share that image file with somebody. I can do so very easily. Additional functions in 2.0 include the coordinate system editing, but we've already set that in 5.3D, so we don't need to touch that now, as well as the optimization improvements that I mentioned earlier. So before I move on to InfiPoints DP, I want to hit Save As, and we'll save this as IP DP webinar OC crop. So I've set my optimized, set my coordinates and cropped. Okay, save scene. So we're now finished in .3D, and similar to how we shared directly from 5.3D to .3D, we're now going to share directly from .3D to InfiPoints DP. So I select Share to InfiPoints, Export Scene with the user-defined coordinates. And that opens up InfiPoints DP here on Android automatically. No additional buttons or functions are required on your end. As soon as it opens, it starts converting. So this is recognizing any surfaces and cylinders automatically within your scan data and intelligently recreating those as CAD objects for you to then export, as you see in the top left of the screen, as an IGES or a DWG file.
So while we're waiting, I think I can answer some of the questions that we have here.
Perfect.
Yep, there's about 10 questions asked already. The first question that we've received is, where are the applications in your shipbuilding arena being used? So if this is mentioning about InfiPoints, we have a few use cases with InfiPoints in shipbuilding, for example, with BWMS use cases, replacing those equipment inside of ships, or rerouting piping throughout the small, narrow inner parts of the ship and things like that. So there have been a lot of the success of InfiPoints has been from applications where 3D models are necessary, or using installment or carrying out an equipment out of a facility kind of use cases where our capabilities shine the most. So
sure, and I can speak to that too if the question was about DotProduct and the DPI-8X. Our shipbuilding customers are using it in very similar applications to any industry that we're in, whereas it is renovation, repair, ongoing construction progressing, as well as quality control and ship check procedures to validate assets on the ship with a very small, easily deployable solution. So yeah, it's a variety of applications, but it is a very good fit for our technology due to the close quarters interior spaces that need to be documented. So here we see it is finished processing and automatically rendered all the surfaces and pipes within our scan. So that's going to be used as a reference, for example, if I was trying to design a new installation to go into this space, I now have a clean, lightweight CAD model to bring directly into SolidWorks. So if I select Export IGES, that's going to be my next step. And I'll call it IPDP webinar. Okay. And that is now exported and saved onto the hard drive of my tablet. And I'm just going to email it directly to Shun. So I'm opening up ES File Explorer. It's a simple Android file browser. So you could be using any Android file browsing application. And in this case, I'm using ES. I'm going to go to my point clouds, my webinar folder. And then the file that I just saved is IPDP webinar. So I'll tap and hold and select to share via email. So I've typed in all the relevant information. You'll see the 683 kilobyte file is attached very easily. And I'll select send. So that file that we scanned live here today is now on its way to Japan, where Shun will be able to show us the easy import process into SolidWorks.
So now I have received the file from Chris by email. I'm now going to save it to my computer. So now I think I'm showing the screen right now.
Confirmed?
Yes, and then I'm just copying the IGES file that was sent by Chris. And let me just open that in SolidWorks. So it's easy as that. And just within a few seconds, you're with the model that was extracted automatically from the point cloud and into a mechanical CAD system in a matter of minutes or seconds. And then you can see here that that the elements that were extracted are each element is separated. So you can work from here to model something more sophisticated and use this data for your downstream workflows. So of course, this is an IGES file that we exported right now, but we can also export a DWG file, and of course, these CAD formats can be imported into a variety of systems. So SolidWorks is just one example here that I just showed today, but I can do it in most of the mechanical CAD systems, as well as the BIM systems that is in the market. So this is how simple it is to go from a scanner all the way to a CAD system in a matter of a live demo like this. So yeah, so this is just how our Elysium technology of extraction and handling 3D geometry will work within the interoperability that we have with the CAD systems. Okay, so I think I would like to go back to the PowerPoint presentation again, if you can do that, Chris.
Sure thing. So we've now taken this process to completion, and I'll move on to the next slide.
Okay, so one of the reasons why we wanted to do this webinar at this timing was to introduce this new pricing scheme that we are planning. So we've had the $99 per month monthly subscription of this InfiPoints DP program, which you can use, and we're going to introduce an yearly subscription of instead of paying $99 per month for 12 months, we're offering a $999 per year yearly subscription to use the automatic feature extraction capability in the DPI-8X. So this and of course this InfiPoints DP is embedded in all DPI-8X scanners, and you have a 30-day free trial with this. So for those of you who have the scanner but haven't had the chance to try it yet, feel free to test it out. And we're always all open for any feedback on the functionalities or on any questions that you may have. And we look forward to having more interest and having more positive feedback and constructive discussion about how this could build your workflows.
And I encourage all users to visit the DotProduct website, where you can find the InfiPoints DP page, which has the relevant links. Or if you go to Buy Now software subscriptions, that's where you can get access to your 30-day trial license, or you can start your subscription for the monthly or yearly option, which the yearly option will be released next week.
Yep. And if you want more information about InfiPoints itself, feel free to visit our website, Elysium website. Actually, we've renewed our website just today. So feel free to look at the information there and let us know if you have any questions there too. So I think we've gathered a lot of questions from the crowd today. Let me try to answer as much as possible. So the first question we have is, how well does the scanner work in low light situations like in mines? I think it's a question for you, Chris.
Sure thing. So the answer is it works very well. Dark conditions are no problem. A challenge we do have with the scanner is direct sunlight. So I do bring that up anytime this comes up. There's ways around that where you can scan in the early morning, evening, on a cloudy day, or in a shaded environment, and it will work outdoors, but not in direct clear sunlight. Back to the dark scanning, one of the few optional hardware add-ons we have is a light kit that attaches directly to the top of the scanner, and that allows you to capture full color shadowless data even in pitch black environments. It's just a couple $100 add-on, and it totally solves any issue with dark areas because it is wider in field of view than the camera itself, so it's capturing good clean data with no shadows. And there's more information on that light kit on our website as well.
Okay, thank you, Chris. So the next question is, can any tablet be used, or does it have a specific tablet?
It does have a specific tablet. We have in the history of the product and our multiple versions had different tablets that we've chosen to operate on, but it does come with the tablet. So it is a complete solution built for the form factor and processing power of this tablet. So we are currently exclusive to the NVIDIA Shield, although, as more better tablets continue to come out, we may upgrade that and are open to suggestions on new tablets. But currently it is NVIDIA Shield exclusive, although it is all included. And you can actually purchase a second tablet or a third even if you want to extend your battery life. That is an optional workflow we have as well, where you can just swap the tablet out in the field. It slides in and out very easily. So it's all designed around this tablet today, the NVIDIA Shield.
Thank you. So the third question is, are there any restrictions in the shining surfaces? So I think this refers to any reflecting areas, I guess?
Yeah. So the answer is a pretty clear yes and no. As with almost any scanning solution, there can be a little bit of challenges with dark blacks or shiny objects, but the good news is that it's not much of an issue with our sensor. The only material that I would say you can't capture is a truly polished mirror. That would give you some stray points or some lack of capture, but that's not the case for anything else shiny, for any blacks. All of those can be captured. And the really powerful aspect in our technology is the fact that you can see in real time what you have and have not captured. And the trick with those challenging areas is just to approach them from different angles and distances while you're doing that live scan, and it'll 9.9 times out of 10, it'll fill it all in as long as you just approach it from different angles and sides, unless, like I said, it is a truly polished mirror. That would be the only exception to that.
Okay, thank you. So next question is there a max area that can be stitched together? So for example, can I do like an entire 4,000 square foot home or a 10-story building, or what does the workflow there?
So practically, yes. Technically, no. So you could continue linking scan after scan after scan. However, anytime you're doing that, you are running the risk of introducing drift in your data. So unless you're using a lot of survey control points that have been measured in to reference it, you wouldn't necessarily want to link more than up to, say, at most 10 to 15 DotProduct scans together. Another important workflow to remember is if you are using the append feature to link them, you would want to scan your centermost area first and link each of those additional scans back to the center area. That keeps your data nice and tight and avoids any of that drift that you might be at risk to if you link scan after scan after scan. It's also, a practicality thing. We're scanning small to medium-sized areas in each scan. About the size of your typical bedroom could be one scan with this device if we're talking, full detail capture of floor, ceiling, walls, etc. So you can scan a whole house, but you're not going to scan a whole building. That's still going to be a project for a traditional tripod laser scanner. So this has the right fit for room size, small and medium areas, but it's not going to be an entire building solution.
Okay, so the good thing is we have a lot more questions, but we're almost out of time here. So let me take two last questions here that I have on the list here. Okay, so what is the battery life for one tablet?
Sure, the battery life is 2 to 3 hours of continuous scanning. So that's if you're scanning and or optimizing the entire time, it'll last for 2 to 3 hours. If you're taking any breaks or powering down between scans, it'll last for a lot longer than that. And same goes for the light kit, so that they match in battery life if you're using that. As I mentioned earlier, you do have the option of adding a second tablet for just about $300, and that allows you to hop swap in the field and scan continuously if you're trying to maximize scans in a single day.
Okay, so one last question. I'm sorry, everybody that asked more questions, but what is the smallest object with level of accuracy that can be recognized and captured with the product? So, is wiring something that's being able to be captured, or?
Sure. Yeah, so you can definitely capture wiring, especially given that you have the RGB values as well to show them if they're along a wall, for example. But if we're talking, what's the thinnest wire, floating in the air, or thinnest pipe floating in the air that you can confidently capture? I would generally say an inch, maybe a little bit thinner than that, maybe a ½ inch. The accuracy at close range of the device is going to be a 1/16 to an 1/8 of an inch. But as far as thin, discrete objects go, I would put it at more at a ½ inch or more. It is going to give you accurate data on discrete objects, but it may not be as complete given the nature of the point cloud and the frames that are being stitched together.
Okay, so thank you, Chris, for answering the questions. And I know that there's a few more questions here in the list, but we will get back to you individually with these. So thank you very much for everybody that attended today, and we look forward to having more communications for every one of you that attended this webinar. And as I explained, this webinar will be recorded and will be distributed to all attendees and all people that registered. So please look forward to that as well. So Chris, do you have any final words?
That sums it up. Thank you for your time today, and please contact both of us directly with any further questions, and we'll be following up with those of you who have questions that we didn't get to already.
Yes, so thank you very much for everybody that joined today, and have a nice day.